Have you ever wondered what goes on behind the scenes when you look at a screen? Every image, every video, every word you see is made up of countless tiny building blocks called pixels. But what exactly is a pixel, and how does it magically appear on your screen from lines of code? In this video, we'll embark on a fascinating journey to uncover the secret life of a pixel. We'll start by understanding what a pixel is, then explore how it's represented in computer code, how your graphics card processes it, and finally, how it transforms into the vibrant images you see on your display. This content is for anyone curious about how digital images are created and rendered on a screen, from aspiring developers to tech enthusiasts. At its core, a pixel, short for picture element, is the smallest controllable element of a picture represented on a screen. Think of it as a tiny colored dot, a single point in a digital image. Billions of these dots work together to form the high-resolution images we see every day. Pixels are fundamental to digital imaging. Their density and color accuracy directly impact the quality and clarity of what you see. Understanding pixels helps us appreciate the intricate process behind every visual experience on our devices. Now, let's dive into how these tiny dots are represented in the digital world, starting with the very code that brings them to life. In the most basic sense, a pixel is stored as a numerical value in a computer's memory, usually in binary. Each pixel's color and intensity are assigned specific values, often represented by a combination of bits that tell the computer what color to display. The most common way colors are represented for pixels is using the RGB model, red, green, and blue. Each of these primary colors is assigned a numerical value, typically from 0 to 255. By combining different intensities of these three colors, a pixel can display millions of distinct shades. Once the pixels are defined in code, how do they get to your screen? This is where the graphics card, or GPU, becomes the unsung hero. The graphics card is a specialized processor designed to quickly manipulate and output images to a display. It receives commands from the computer's CPU about what to draw, the shapes, textures, and, crucially, the colors of each pixel. The graphics card then renders these commands into an image buffer, a temporary storage area in its memory where the complete image is assembled pixel by pixel before it's sent to your screen. Now, let's explore the final leg of the pixel's journey, from the graphics card's buffer to your display. Your screen doesn't just display the entire image at once. It scans the image buffer line by line, typically from top to bottom, sending the color information for each pixel. This process happens incredibly fast, often dozens or hundreds of times per second, known as the, quote, refresh rate. Once the color information for a pixel arrives at its designated spot on the screen, the display technology takes over. For example, in an LCD screen, tiny liquid crystals twist or untwist to allow or block light from a backlight, creating the specific color for that pixel. Different screen technologies employ various methods to bring these pixel colors to life, each with its own advantages. Common types include LCD, LED, OLED, and even newer technologies like microLED. While they all rely on pixels, their underlying mechanisms for producing light and color differ significantly. LCDs use a backlight and liquid crystals to modulate light. OLEDs use organic compounds that emit their own light when an electric current is applied, allowing for true blacks and vibrant colors, as each pixel can be individually turned on or off. And there you have it. The incredible journey of a pixel, from a few lines of code to a vibrant point of light on your screen. It's a testament to the ingenuity of computer science and display technology that billions of these tiny, seemingly insignificant points of light can come together to create the immersive and detailed visual worlds we interact with every day. As technology advances, pixels will continue to evolve, becoming even smaller, brighter, and more dynamic. What new forms of visual experience will the pixel enable next? The future of display technology promises even more breathtaking innovations.